The geological record of Earth spans approximately 4.5 billion years, and the portion of that record that humans have been able to read with any precision covers only a small fraction of that duration. We've been doing systematic science for a few centuries. We've been doing geology for less than 200 years at any level of sophistication. The deepest layers of sedimentary rock that preserve the evidence of ancient life extend back 600 million years to the Cambrian explosion, and the deeper layers before that, the Precambrian, are largely silent on questions of complex life because complex life had not yet evolved. Within the portion of geological time that complex life occupied, there is a span of roughly 300 million years during which the planet supported large, complex, cognitively sophisticated animals that were in some respects more capable than the animals that preceded them. And then, within the most recent sliver of geological time, the last 3 million years, a primate lineage in Africa began a trajectory of cognitive and technological development that eventually produced, in the last 12,000 years, the civilization that exists today. The question that a small number of scientists and a much larger number of thoughtful non-scientists have asked is this: could the same trajectory, or something resembling it, have occurred before? Not in a different solar system, not on a different planet, but here, on Earth, long before the geological layers in which we have been looking for evidence were deposited? The question is sometimes called the Silurian Hypothesis, after a name given to it by two researchers in a 2018 scientific paper. And while the honest scientific answer to it is that there is no evidence of any prior industrial or technologically advanced civilization on Earth, the question itself is more scientifically interesting than the absence of evidence might suggest. Because the absence of evidence and the evidence of absence are not the same thing. The Silurian Hypothesis was formally articulated in a 2018 paper by Adam Frank of the University of Rochester and Gavin Schmidt of the NASA Goddard Institute for Space Studies, two serious scientists, who were not proposing that a prior civilization existed, but were asking what evidence we would expect to find if one had, and whether we would in fact be able to detect it. Their conclusion was sobering. If an industrial civilization had existed 60 million years ago, at the level of technological development comparable to the early 20th century, burning fossil fuels, manufacturing synthetic chemicals, altering land use patterns, the geological evidence of that civilization would be, by now, almost entirely undetectable. The surface geology of 60 million years ago is deeply buried, transformed by geological processes of subduction, erosion, metamorphism, and sedimentation that have obliterated or altered most of the physical record of that time. The plastics that our civilization produces would not survive 60 million years. The steel structures would oxidize and become unidentifiable iron deposits in the sediment. The radioactive isotope signatures of nuclear activities might leave traces, but only if someone knew precisely which rock layers to look in and what specific anomalies to measure. Frank and Schmidt concluded that the only potentially detectable signatures of a prior industrial civilization would be chemical anomalous ratios of certain isotopes, unusual concentrations of industrial byproducts in sedimentary layers, changes in the carbon isotope record consistent with large-scale fossil fuel burning. And here is what makes their paper genuinely interesting. Such anomalies exist in the geological record. The most famous is the Paleocene-Eocene thermal maximum approximately 56 million years ago, during which the global climate warmed dramatically in a geologically short period, and the carbon isotope record shows a pattern that closely resembles what we would expect from massive fossil fuel combustion. The PTM's cause has been attributed to natural geological processes, volcanic activity, methane hydrate destabilization, and there is no credible scientific evidence linking it to any prior civilization. But the question Frank and Schmidt raised, whether we would be able to tell the difference, has no fully satisfying answer. The deeper challenge in assessing the possibility of a prior technological civilization on Earth is the completeness of the geological and archaeological record, or more precisely, its incompleteness. The fossilization process that preserves biological remains in rock is extraordinarily selective. only a tiny fraction of organisms that ever lived are preserved as fossils, and the organisms most likely to be preserved are those with hard skeletal structures who died in environments where rapid burial under sediment was possible. Soft-bodied organisms, organisms that lived in upland or inland environments far from deposition or basins, organisms that decompose rapidly after death. All of these are vastly underrepresented in the fossil record relative to their actual abundance in the living world. The fossil record is, by the best estimates of paleontologists, a catastrophically incomplete sample of the organisms that actually lived, representing perhaps a few % of species and an even smaller fraction of individuals. For comparison, archaeologists studying human civilization from the perspective of far future investigators would find, in the geological layers deposited by our civilization, the chemical signatures of industrial activity, the isotopic anomalies of nuclear technology, altered pollen profiles from agricultural transformation of the landscape, and perhaps some surviving artifacts in geological contexts favorable to preservation. The concrete foundations of our buildings might leave impressions. The clay layers of fired ceramics might survive in some contexts. The chemical composition of our atmosphere, recorded in ice cores and cave formations, would show the distinctive carbon dioxide signature of massive fossil fuel combustion. But they would not find the overwhelming majority of our cities, our technology, or our written records. Because these are composed of materials that degrade rapidly in geological timescales, and because the processes of erosion, subduction, and metamorphism that operate over tens of millions of years destroy the kind of surface and near-surface deposits in which our civilization exists. The fossil record of intelligent hominids goes back only a few million years, a vanishingly small fraction of the time during which complex life has existed on Earth, and the evidence of our cognitive sophistication in the geological record will be largely erased within tens of millions of years of the end of our civilization, leaving only the chemical and isotopic traces that Frank and Schmidt identified as the only potentially surviving signatures of an industrial civilization. Before humanity, the planet supported multiple lineages of animals with significant cognitive capabilities over geological timescales that dwarf the duration of human civilization. The dinosaurs, specifically the derived theropod lineage from which birds evolved, existed for approximately 160 million years before the Chicxulub impact ended the non-avian dinosaur lineage 66 million years ago. Troodontids, dromaeosaurids, and the broader Coelurosaur group included species with brain-to-body ratios and neurological complexity approaching those of modern birds, whose cognitive capabilities, including tool use, problem-solving, and complex social behavior, are increasingly recognized as extraordinary. Dale Russell, a Canadian paleontologist, proposed in 1982 a thought experiment in which he modeled the evolutionary trajectory that the troodontid Troodon formosus might have followed had the Chicxulub impact not occurred, a model he called the Dinosauroid, projecting that the selective pressures acting on an increasingly cognitively sophisticated theropod lineage over tens of millions of additional years might have produced something with an enlarged cranium, bipedal posture, and manipulative forelimbs capable of fine motor tasks. The Dinosauroid was a speculative model and has been substantially criticized on paleontological grounds, but the underlying question it raises, whether given sufficient time, the selective pressures on cognitively sophisticated dinosaur lineages might have produced something qualitatively different, is not answered by the criticism. Whether any dinosaur lineage was actually on a trajectory toward the kind of technological intelligence that humans developed is a question that paleontology cannot definitively answer, because the neural tissue that would contain the answer does not fossilize, and the behavioral evidence of cognitive sophistication leaves only the most fragmentary traces in the rock record. The same applies to the mosasaurs and plesiosaurs of the Cretaceous seas, to the large-brained therapsids of the Permian that were the ancestors of mammals, and to the remarkable variety of complex organisms that populated the Carboniferous and Devonian periods, all of whom lived and died and left records so incomplete that their full cognitive and behavioral repertoire is largely unknown to us. The 99% of species that ever lived that are not represented in the fossil record includes, by definition, species whose full characteristics we cannot assess. The specific question of whether a pre-human intelligent civilization could have arisen on Earth before the current geological epoch requires distinguishing between two different claims that are often conflated in popular discussions of the topic. The first claim, that an industrial or technologically sophisticated civilization comparable to modern human civilization existed on Earth before the emergence of hominids, has no supporting evidence and faces the additional challenge that such a civilization would have required a primate-equivalent neurological platform that the fossil record of the relevant geological periods does not clearly identify. The second claim, that cognitively sophisticated organisms with social complexity, tool use, and communication systems that might broadly qualify as cultural existed on Earth in geological periods prior to the Holocene, is supported by considerable evidence. Cetaceans have sophisticated communication, demonstrated cultural transmission of learned behaviors, and social structures whose complexity is not fully understood. Sperm whale coders, humpback song dialects that spread across ocean basins as acoustic fashions, orca family groups with cultural practices that differ between populations in the same geographic area. Corvids demonstrate tool use, planning, and theory of mind. Crows have been documented manufacturing tools from multiple components, planning for future needs, and understanding what other individuals do and do not know. Octopuses demonstrate problem-solving and behavioral flexibility that neuroscientists find genuinely surprising given the radically different architecture of their distributed nervous system. A brain, organized so differently from the vertebrate brain that the cognitive achievements it produces represent an entirely independent evolutionary invention of general intelligence. These are not ancient lineages in the geological sense. Cetaceans and corvids are Cenozoic in origin, but they demonstrate that the cognitive capabilities we associate with advanced intelligence are not uniquely human products of a unique evolutionary trajectory. They are apparently the kinds of capabilities that evolution produces repeatedly under the right selective pressures in lineages as different from each other as whales, birds, and cephalopods. The practical scientific implication of the Silurian hypothesis, the reason Frank and Schmidt wrote the paper as working scientists rather than as speculative enthusiasts, is its relevance to the search for life beyond Earth. If an industrial civilization had existed on Earth 60 million years ago and left only chemical anomalies in sedimentary rock, then the detection of any prior civilization on another planet using remote observation from a telescope from a spacecraft flyby would be essentially impossible. The implications for the search for extraterrestrial intelligence are significant. We may be looking for the signatures of currently active civilizations because those are the only signatures we could detect at interstellar distances, while the geological records of extinct civilizations on other worlds would be as invisible to our instruments as a 60 million-year-old industrial civilization on Earth would be invisible to our geology. This has a further implication that is even more unsettling. If the universe is 12 billion years old, and if civilizations can rise and fall in timescales of thousands to millions of years, then the geological record of every habitable planet in the galaxy is likely full of the buried, undetectable signatures of civilizations that came and went before any radio telescope was pointed in their direction. We are not searching a universe of silence. We may be searching a universe of archives, of records written in geological chemistry that no instrument we have built can read from a distance of light years. The Silurian hypothesis is therefore not primarily a claim about Earth's past. It is a statement about the fundamental limitations of the search for intelligence in a universe old enough that civilizations could have risen and fallen many times before the current era, leaving behind only the faintest chemical whispers in the stone. The emotional and philosophical dimension of the question, what would it mean if we were not the first? If the trajectory that produced human civilization had been traveled before by something else on this same planet is worth dwelling on, because it changes the meaning of the geological record in a profound way. The 4.5 billion years of Earth's history are not simply a prelude to the emergence of humanity. They are a duration of extraordinary length within which the conditions for complex life, cognitive sophistication, and potentially something approaching civilization have existed for hundreds of millions of years. The Carboniferous forests that formed the coal deposits we are now burning and were buried and became stone before the first dinosaur drew breath. The Permian oceans were full of complex, intelligent, socially sophisticated animals for tens of millions of years before the greatest mass extinction in Earth's history erased 90% of marine species and reset the biological clock. The Triassic recovery produced new lineages that became the Jurassic world, which became the Cretaceous world, which ended in the impact winter that opened the Cenozoic, and through all of this, through 250 million years of complex animal life before a primate in Africa first made a stone tool, the planet was inhabited by organisms whose inner lives, social worlds, and cognitive landscapes we can only guess at from the shapes of their bones and the patterns of their teeth. If the question is not whether such conditions existed, but whether they were, on at least one other occasion, sufficient to produce something we would recognize as intelligent, the honest answer is that we do not know, and that the absence of clear evidence is at least partly a consequence of the nature of the geological record, rather than a reliable guide to what actually happened. The rock does not remember everything. Most of what has happened on this planet has left no trace that our instruments can read. The archive is fragmentary, and the fragments we have are those that happen to survive the specific processes of preservation and exposure that make the geological record visible to us, not a representative sample of all that existed, but a biased and incomplete selection from which we draw conclusions that are inevitably constrained by the limits of what the stone chose to keep. What the question of prior civilization on Earth ultimately invites is not the comfortable certainty that we are first and alone in the deep history of this planet, but the more interesting and more honest uncertainty that comes from understanding how much we cannot know. The geological record tells us what happened in broad strokes. It does not tell us everything that lived and thought and made and communicated in the hundreds of millions of years between the Cambrian and the Holocene. We are a young species reading an old record with instruments that were not built for the task, looking for signatures of intelligence that we assume would resemble our own, in layers of rock that have been transformed by processes indifferent to the information they destroyed. The stone is deep and old and mostly silent, and the silence is not evidence of emptiness. It is evidence of time, of the particular, selective, and often cruel process by which the past decides what it will reveal to the present and what it will keep for itself. Locked in layers too deep to read, changed beyond recognition by the slow and patient forces that transform everything that was into something else entirely. We may be first. The evidence does not prove otherwise, but the evidence also does not prove that we are. And in the gap between those two statements, in the space carved out by geological time and the incompleteness of the record, the question remains open, honest, and worth asking.